All right, everybody, all of you who are on time, welcome to the webinar. My name is Andrew Jones. I am the co-founder and executive director here at Climate Interactive. I'm here with Ava De Leon. And if you are interested in hydrogen dynamics, climate change, and En-ROADS, you're in the right place. We're going to get going in a few minutes. Until then, we'd love to hear why you're here using this poll. Would you please go to this link, open another browser tab, and look in the chat. I bet Ava has put this link, polev.com, climate935, or you can use this QR code, or you can do it by text. But come in here and share, what is it about the topic of hydrogen and En-ROADS that inspired you to join today? Why are you here? Also, if you want to in chat, say your name and where you are. We're always fascinated to hear where people are from around the world. We did this at 7 a.m. Eastern this morning, and we had people in Gabon, people from China and India and Southern Africa and Europe. Now we have more Americans, I'm guessing. Hydrogen is in the news a lot as a solution. You're an energy engineer. You're passionate about energy modeling and simulation. Fantastic. I use En-ROADS in your classroom. Great. Keep doing that. And Ava, actually, would you post the guided assignment? Make sure that any educators have access to that. It's a great way to use En-ROADS. Hydrogen is, and also post, if you're using the model, you might want to be part of our training course that we have right now. This is the last day to apply. It is a cohort of people learning to use En-ROADS. Learn more about green hydrogen potential in hard to abate sectors. It could be part of a future solution. People keep mentioning it. Doesn't that happen? I run these workshops too. What about hydrogen? What about hydrogen in an En-ROADS workshop? Learn about how to use En-ROADS for teaching purposes. Broadening your climate solution literacy. New technology that could be simulated in En-ROADS. I get to use new features when I use the simulation. Stay up to date on the new features in En-ROADS. Great. Particularly as a tool to identify real versus false. High priority, low priority. Hear from friends that the engine manufacturing industry is in the future, but you have your doubts. You're doing a master's on green hydrogen. We use it at school. I want to know about hydrogen solutions. I would like to get a better feel for the potential of hydrogen, a local engineer, a hydrogen house, interested to see how it might be a solution. You're Ellie, you're in Boston, you know very little about hydrogen, but you use En-ROADS in a climate adaptation course and you love it. Curiosity, you know very little about this. You teach learning opportunities. Great. Metallurgic reductant. Okay. Most of it comes from oil. It's being sold as green. It's a false solution. Is hydrogen a future solution to combat climate change? Great to see the questions. It's becoming referenced more often as a clean fuel of the future. You want to know pros and cons. Okay. If you're just joining, I am Andrew Jones. I am the co-founder and executive director of this climate tech nonprofit, Climate Interactive. We work closely with MIT Sloan and the team there. And I'm here with several members of our team, Ava De Leon, Kaveh Dayanati, and someone else, I can't see their name, but they're here, and Sam Wellington. We're thrilled that you are here, and let's dive in. Oh, you love my webinars. Love to hear it. Fantastic. Okay, here we go. Here's who we are. At MIT, it is the Sustainability Initiative and the Climate Pathways Project that we work with. And we want to acknowledge the 4 hydrogen modeling heroes of the month, Kaveh, Clara, Lori, and Sam Wellington, who did the heavy lifting underneath what you're about to see. Okay, we're going to talk about the motivation, we're going to talk about simulation results, and we're going to try to save a good bit of time for questions with the modelers. Climate Interactive, why are we here? When we look around the world, we see the power of top decision makers in government, in business, in nonprofits. However, there's a big challenge out there. The information that they're getting is not grounded in the best available science. There's so much propaganda, so much lobbying, or just relying on intuition in order to think about what are high leverage solutions and low. And when we engage them, often we just say, here's a book, here's a PDF, read this, change your mind. We think that changing your mind is a more intense process where we want people to think for themselves. That's why we've made this simulator En-ROADS to let you very quickly simulate different futures, see what the results are, see it in a format where things change so it's engaging. You can bring it in front of many different audiences, and they very quickly learn, for example, the effect of energy efficiency on emissions over the long term and temperature and whatever impacts that you care about, which might be, because there's a heat wave going on here in the US, extreme heat days wherever you may be. So that we include those maps as well. The model is here in 21 languages now for use around the world. Over 1 million people have used it. That's what we're going to be digging into. But the topic of the day is going to be about hydrogen. And I remember 1988 when my mentor, Dana Meadows, who wrote several of the books behind me there, started talking about this vision of hydrogen as a carrier. Hydrogen is primarily used, as you all know, as a feedstock in industrial processes and oil refining and fertilizer and some chemicals. But what if it could carry energy, much like electricity carries energy for energy storage, or really it's a bunch of pipes and tanks and these kind of systems that could use it in several different sectors. What really could be the potential here? Before laying out and getting more into our analysis, we really just want to hear your curiosity, your perspective, and also what's your assessment? What is your assessment? So please go back to the poll. Before doing this exercise and going through it, where do you sit? Encouraging hydrogen as an energy carrier. Now, note, I haven't said much about the issue, but I'm very curious to kind of know, where do you sit? And we're just curious if, you read the headlines and boy, it's getting a lot of press and a lot of attention. What's your take? Medium. Medium has 42%, but then there's an even split between high and then low to zero. Okay, medium is where most people are coming out. Medium, oh, here comes low. Low is climbing. Low is climbing now. Low and zero are about even with medium right now. But there's a good diversity of perspectives here. Thank you. This is really helpful. Now, when you think of it, we'll show this later, but there are many different types of hydrogen and sources. There's very little that we can find in the ground. We call that white hydrogen, but there doesn't seem to be much at all. But green, wind, and solar, there's this idea of blue hydrogen, gas, primarily gas with carbon capture and storage. Pull it from the grid is yellow, pink, nuclear, brown, coal, gray, which is from natural gas. Now note, this is speculative. This does not exist at scale yet. So I'm asking you really for your impression. And here, as you might expect, most people are saying, well, let's see what is the future of green. Another question, where you imagine it. It could be used in a variety of places. Again, mostly imagined. This doesn't exist yet. Electricity storage, where wind and solar is variable. So if we use it to make hydrogen, store hydrogen, I showed you those tanks, store it, and then when you need it later, in a different season or a week later, you could use that. Is it storage or directly in buildings? Not so technically likely to happen from what I can tell, but if it did happen, we could explore that in industry, particularly steel and iron making, air and water. This is ships. This is airplanes. Doesn't exist yet. Maybe it could. Or right now, I told you about the feedstocks, decarbonizing current use. but most are saying let's explore it for storage. Great. Thank you. Okay. So helpful to hear where you're coming from. And boy, when it comes to the people who are excited about it, other countries seem to be at least coming up with the plans. Here is an interesting summary of investments in policy. In China, capacity additions on electrolyzers. This is what you use to separate the hydrogen and the oxygen using wind or solar or another process. Um, they are leading additions with a capacity of large capacity and 9 gigawatts in advanced stage development. EU is using some regulation in order to build it and a large investment, $2 billion. India has a program called Strategic Insight Interventions for Green Hydrogen Transition. SITE, a friend of a friend talked to one of the leading climate people in India and said that a large part of their climate strategy was built around green hydrogen. UK has a standard that they've put forward. In the Inflation Reduction Act, the United States put forward 1.7 billion for 6 projects and then some incentives, $3 per kilogram as a subsidy for the use of hydrogen. However, it looks like just in the last few weeks that funding has been rescinded, so that bullet is not correct anymore. The point is, it's a lot of investment that is happened and a lot of hopes. Our team put together this image to share existing perspectives on it. And over on the far right is the highest level of optimism about the future of hydrogen as an energy carrier. Now, mind you, this is from the trade group. Their job is to say this. But here it is, the Scaling Up Report 2017 from the Hydrogen Council. Ava, if you have a link to this, can you post that? And it says, it is a central pillar of the energy transformation required to get us below 2. And remember that number, 18% of the world's final energy demand by 2050 is what they're saying. More in the middle, DNV. Their energy transition outlook is something that we look to a good bit. They say it's expensive, it's inefficient, particularly relative to electrification, its main competitor. It should be thought of a low carbon resource source as a last resort. However, they say it's desperately needed, particularly in the sectors where it's difficult or impossible to electrify. And then on the other end is our respected colleague, Joe Rome, formerly of like DOE in the Clinton administration, and now at UPenn. He wrote the Climate Progress blog, and he just did a reissuing of his 20 year ago, The Hype About Hydrogen. Joe, I think you're on this call. I think I saw you registering. You are welcome. Hooray. Here you are. And here he writes about hydrogen, but also direct air capture and some other things that don't seem to be adding up to make a big difference. But he says neither government policy nor business investment should be based on the belief that hydrogen energy technologies will inevitably be even a small contributor to decarbonizing. And Ava, would you put a link to that book in the chat? So, what does Climate Interactive do? We are here as your neutral broker of the math of how technologies and policies interact with this complex system to deliver upon emissions reduction or increases, depending on the policy, temperature reduction, and the impacts. As a neutral broker, we're here to say who's right, what assumptions do you need to make to decide who's right about this, and do it in a way that you can replicate those results for others. So here's the exercise today. Both, I want to show you how you can use En-ROADS to answer those questions. When someone says, hey, facilitator, here in Uruguay in our En-ROADS workshop, what about hydrogen? I'm going to show you the graphs and things to look at in order to engage people on the topic. But on this issue of actually sharing our insights, here's how I want to do it. What we did is that we looked at others' forecasts. So imagine that the technological, societal, policy hurdles, we get over them. And if you read Joe's book, you're going to believe that we're not going to get over them and it's not going to grow like this. But we thought our contribution could be if it did grow the way that several other modeling groups had it grow, what would be the marginal contribution of hydrogen? Is it a big deal? Is it a small deal? Right now, it's lumped in with lots of other solutions in these other studies. But what's cool about En-ROADS is you can pull out anything and say, is this a priority or is this not a priority? So we're going to look into the context of this in priorities, but I do need to make a little speech about priorities briefly. Why are we emphasizing priorities? Why are we not saying, oh, every little thing counts, let's just do all of the above? That's because of some of the recent data on temperature. This is temperature from 1860. This is the scenario that many believe we may be on. But look at those two dots of temperature in these last several years. The dot is there and there. Temperature is going up even more. The urgency of finding solutions that will get emissions to fall and temperature to start balancing out soon is incredibly urgent because of the suffering and deaths that are going on around the world. Because we haven't bent this curve of atmospheric concentration. These are the data from Mauna Loa showing how much of this blanket is over Earth trapping heat. Why? And the other data is that despite the clean energy revolution, despite so many solutions that have been deployed, coal, oil, and gas emissions continue in blue, in black, in gray, and brown to go up. Therefore, we must focus on priorities. What is a priority? Something that could reduce greenhouse gas emissions in the next 10, 15 years. Peak them, have them fall steeply down. That's what we mean priorities. Why would we spend time on other things that aren't? Okay, that's my priority pitch. So, back here, what we did is we created a scenario that was consistent with some of the more optimistic scenarios from Equinor, that's up there in purple, the purple line right there, that goes to 4% of final energy consumption by 2050. Another one is this dotted line, which is Bloomberg New Energy Finance net zero, goes up to 7%. There's another one which is more blue, which is IEA, the International Energy Agency, founded by fossil fuel companies, net zero as well. So see, they're at 4, this one's at 7. So this blue line, we're going to slowly recreate this blue line and say, what if? If it worked, how much would it help the climate? So look at that blue line. Think if we fall in the middle of Equinor, IEA, and Bloomberg New Energy Finance, and I ask you, what do you think it would do to temperature? So go back over to your poll, and here it comes. Here it comes. If that happened, we had upper end growth, and actually, I'm not going to let you see. I don't want you to anchor on each other. Will it get us below 2 degrees if we get that much hydrogen? 2 to 2.4, 2.5 to 2.9, 3 to 3.1, or 3.2 to 3.3. Note, the baseline is 3.3. The baseline. So let's think of this as in a relative sense. Will it reduce just a little bit or more? And please vote. I'm seeing the votes are coming in fast now. What are you doing? You're simulating your mental model. We don't use these models as answer tools. They're not calculators. They are thinking tools. They work best when first you simulate your mental model, you do your mental forecast, and then you compare against a mathematical model that does a better job with feedback processes and accumulations and interdependencies. Okay, we've gotten a lot of votes. Let's go see how are we doing. Most people think 3 to 3.1, 39% of you. However, 27% of you, 29, think it's actually going to get us below 3 degrees. That's like, half a degree in itself. Some of you, 24%, think it's going to be close to negligible or just very, very small. Some think close to 2, and then 4% of you think under 2 degrees. Great. There's the forecast. Most of you think 3 to 3.1. Let's go try it. Let's go try it here in En-ROADS. And if you want to do all this along with me in parallel, I'm going to copy the scenario link. I'm going to chat and I'm going to send it to you. And oh, and I see something coming up about the model. So there's a lot under the hood. Maybe before I show, I'm just want to flash a little bit under here. I see someone asking, does it account for the impact of hydrogen on methane? Because if you leak hydrogen, it messes with the methane cycle and it keeps more methane in the atmosphere for longer, therefore boosting heat. That is in the model. And just if you're worried about this issue, it is a very, very, very small effect. There are bigger things to worry about than that. But yes, we did include it in the model. By the way, any questions that you have about this, please go to FAQ in Zoom. Go to FAQ in Zoom. And also, you can go here to help. And everything, all the equations in the model are shared here in this technical reference guide. So if you want to go read about hydrogen, market clearing of hydrogen, how did we model that? Here's the structure. And then if you scroll down enough, you're going to be able to go in here and see every equation is here. Every number, every equation is shared in the model. And we actually are going to be sharing increasingly a lot of our other results, like the fit to history for everything in the model, but also the fit to the future, such as how do we compare to the other models, in this case for coal. And Ava, at this time, can you put the explainer in chat? Under here, if you really want to learn more, if you go to help, you'll go to support, and then there's so much here about how to use this new feature right here. I shot a short video of how to explain it. It's all here. Okay. What are we doing? We're going to see if we encourage both the use of hydrogen in the world and the green production of it to a large extent consistent with the IEA and those others. How much does temperature go down? I'm also going to teach you how to show hydrogen in En-ROADS. Okay, it lives in 3 places. It lives under transport. We put it with electrification under here. So you're going to go under here, but the graph to look at, the 2 best graphs over here, it lives in this area, hydrogen production by use. And over here, and I'm going to show you the other way. You can know where it lives, or the search function just got so much better. So I happen to know that it's hydrogen production by color, but also if you just type hydrogen right here, you're going to see all of the graphs. I think this is the one. So this is how is it being produced? And then over on the left is how is it being used? And this is how it's being used right now in the baseline. This is a graph 2000 to 2100. What we have is industrial feedstocks is the only use in the base case. And this is going to be for ammonia, methanol, oil refineries and chemicals, fuels, fertilizer, refrigerants, all of that. Industry, oil refining. Those are the only baseline uses going down into the future. We will add others by making them cheaper so that they actually get investment. Here is how it's being produced. Most is gray, which is from natural gas. A little bit is brown right now. You can see a growing wedge of a little bit of green. I showed you what those were before, but click on here and you can see Yellow is from the grid, and pink is from nuclear, and blue is gas primarily with carbon capture and storage. So this is where it would be coming from. And we're going to be bringing in hydrogen into the context of this overall baseline global. Note, this is not the US, this is not just China, this is the whole world and a fairly conservative future of, well, a good bit of coal still going into the future, and oil and gas, the expanding wedge of wind and solar, bioenergy are as the sources. We add in methane, nitrous oxide, we add in F gases, we have carbon removal, and that's what gives us this overall net emissions, the temperature and the impacts that you see. Okay, what if we encourage the use of hydrogen, the production and use of hydrogen now? We've cleared many hurdles to imagine this future. Let's go and see what it does. Okay, here we're going to start with transportation, shipping, air travel. Down here, scroll down and down and down. If we were to have subsidized the equipment, planes and ships and all that, and the infrastructure needed to support it significantly, and I'm going to push it really high. I have to push it high to create those IEA and other scenarios. Then I'm going to boost it here. And what you see is the blue area in the top left, transport, air, and water, growing, starting in the 2030s, grow and grow and grow. It's now more cost competitive, it's getting investment, and it may grow. If so, over on the right, you can see where would you get it? Well, mostly it's coming from green hydrogen, giving the prices here. Some comes straight from the grid, and some comes from pink, but very little. That's the nuclear. Of course, you could make nuclear cheaper if you wanted to and see more pink. So look at that, see that? If you want to imagine more pink, but we're going to undo that. And so this is the boost in transport, air, and water. Secondly, under buildings and industry, electrification to other uses. You can simulate it in buildings, which of all the applications seems to be the least likely to happen. But if it did, we can see, and actually, why is it least likely to happen? Go look the cost. The amazing team here modeled the cost ratio of hydrogen relative to its alternatives. And I'm going to back this up a little bit and see buildings here in 2020 over 2.5 times cost parity with its competitors, basically electrification and others. It's much more expensive. Here is transport, air, and water is about over double. In industry, it's a little more expensive. So this shows why we're not getting as much. I'm going to go back and get the colors back. And I'm also going to go back forward. We had buildings before. No, we had transportation before. Now, buildings. If we massively subsidize the purchase costs, then we could get this growth right there. You see more in that teal color. You have to produce more over on the right. And then in industry, and this is the one that, of course, is the most likely in iron and steel making, where it's a feedstock to those processes. And then you see the brown area. So if it grew that much over on the right, we would get more being produced over on the left, where it's being used in these three big sectors. Now, this is just supporting its use in the world, but what if it were subsidized for where you get it? Under renewables, we're going to scroll down here, hydrogen for energy and for storage of wind and solar electricity. This is going to encourage green hydrogen production. So what if it's really encouraged a lot? The IRA said $3 per kilogram hydrogen. What if the whole world had that subsidy? Watch over on the right in particular. Notice the change here, two changes. More production because it's cheaper, But also, what shrinks the most? The yellow. We're not using the grid to make this, and it makes very little sense, frankly, to burn any gas to replace gas or any coal to replace coal. So here we go. We get more overall, and we get more of it coming from green hydrogen. So this scenario that I just created is consistent with those uh, scenarios that I showed you before. So now we have a large amount of growth in hydrogen, both production and using green hydrogen. So the payoff, let's look over on the right and look what it did to temperature. 3.2 it says, and here we are. This is the answer to your poll, 3.2. So it shaved off zero point 0.1 degree of overall warming with this scale of investment. And appropriately, what did it take regarding the world's renewables capacity? Actually, I'll show it this graph here. My team likes this one. Here is the baseline for renewables capacity for production, renewables production. But look how much would need to get built. Look how much relative to the growth currently. We would be dedicating all of those renewables not to competing with coal and gas on the grid in China, India, US, Indonesia, Mexico, Brazil, all the places that are building electrical capacity. Instead, this is just to use electrolysis to make the green hydrogen to go to those sectors to displace the use of coal and gas. So, using a lot of those renewables to get that result. What is going on? Why did we only get that little? Well, the purpose of hydrogen as a climate solution. Now, no, not an industrial solution or an economic development solution. There are many countries that are doing this for those sometimes good reasons. They want to have industrial production and economic development and jobs. That's one reason that people are looking at this. But as a climate solution, it's only useful if it succeeds at crowding out coal, oil, and gas. It crowds out a little bit of coal. It crowds out, in this scenario, a little bit of gas, and it crowds out just a little bit of oil. Why? Three big reasons. First, it's incredibly inefficient and therefore very expensive. So it's not getting the huge levels of growth up to the 18% that some are imagining. Secondly, it's only addressing a small part of a small wedge of these areas of emissions, what sometimes called those hard to abate sectors, hard to electrify sectors. What at these prices hydrogen is able to tackle is relatively small when you look at the overall scale of coal, oil, and gas. And in the transportation sector, it's only tackling one small part of that 15% that is air and water. And third, the time value of carbon is very, very important. I'm going to bring up CO2 emissions for fossil fuels. When does it help this problem? And go back to my urgency case. Look and see in what decade, given the delays in the system of retiring out old capital, bringing in new capital and infrastructure, and building this industry, this is a small solution for the 2050s. Arguably, some could say we need solutions for the 2050s, but primarily the priority should be on things that succeed at reducing emissions in the next 10, 20 years. I'm going to pull up overall greenhouse gas emissions. Here it is. There is all the nations follow the NDCs. Oh, let me pull that up. And just to even follow the Paris Agreement, we would get emissions falling soon. And of course, we get towards net zero by 2050, 2060. Instead, it's massively delayed. So inefficient, expensive, addressing a small part of a small wedge of emissions and massively delayed, it's not making a significant dent in future temperature if the technological, social, political hurdles could be crossed in order to get there. One of the big hurdles that it would face, of course, is how much it would cost. And we calculated the total money spent, what is that, 3.6 trillion a year by 2060 in order to get this modest gain. It also just, I mentioned the opportunity cost before. We saw how much wind and solar would need to get built just to make the green hydrogen. The opportunity cost asks, well, what if we used that amount of wind and solar to compete with coal and with gas? So here's where we were before. This kind of growth just to make green hydrogen. Let's go back over here. And if we were to encourage this and use electrification as a way to get even more, this brings us temperature down even more, using wind and solar to compete directly with coal and gas in order to crowd it out. Okay, I've taken you through an exploration of what if we did recreate this scenario. And what I think you're seeing, we just created the blue line, which is somewhere in between these two. Our estimates, many of you, when you guessed, thought there would be a much bigger benefit. And now I'm laying out some of the reasons why we would see so much less of a temperature effect just from the hydrogen contribution. When we make calculations like this, please note that, well, many of the inputs and parameters, there's a high degree of uncertainty to them. And when we have a moment like that, we're not here to say we're right, everyone else is wrong. Instead, we're very transparent. I showed you the reference guide. You can look at every equation. We also take care to make some of them changeable. So under the assumptions, under hydrogen, and this is where someone asked about leakage and the effect of the methane, because we don't know exactly the effect on the methane cycle, but here it is with temperature. And if the leakage rate is much higher, look at that. Do you see temperature changing? My point is you could imagine testing uncertainty in some key variables around hydrogen. The leakage rate, the rate of improvement in the efficiency of production. We said it's 0.5% a year. Here are the 4 studies that our amazing modelers came up with. And you can, of course, click on them. You should go look at those studies to see where did we get some of these numbers. And that's another one of the variables that you can change. Another is the progress ratio, the steepness of the learning curve. The more you produce through electrolysis, how much cheaper does it get? And right now, every doubling of cumulative installed capacity of of production via electrolysis reduces the cost 15%. That's 1 minus 0.85 right there. Here's the source, Dietz and Wiende. You can change that, and also the policy phase-in time. Maybe it's faster, maybe it's slower. That'll affect things. So that's our main finding. Both this as here's a tool for you, but secondly, we're seeing this fairly modest contribution. Now what I'm going to do is just pause for a second. I haven't looked at the chat yet, and ask my colleagues, and Kaveh in particular, you built most of this. You wrote these conclusions. You know, it's Sam and Catherine and Ava, others who are on here, but in particular, uh, you heard how I tried to just made my conclusions. Particularly Kaveh, what would you add? Is there a nuance to what I just said that as a person who is the most deep into the model in this sector? And once again, give it up. Thank Kaveh. Somebody in chat, thank Sam and Kaveh and the team. But Kaveh, any nuance you would add to my conclusion there?
Thanks, Drew. I think you put it quite succinctly. The issues are the efficiency mainly, which make it a very expensive solution. The issues is that it's not really very competitive as we can show using our cost ratio graphs here. You didn't show any of the cost ratio graphs, but the users can have a look at the relative cost efficiency of hydrogen equipment versus electric equipment, for example. Uh, not just from an energy perspective, but from a total cost of ownership perspective. So it takes a lot of subsidies to make it cost competitive. And as you showed in the renewables primary energy demand for hydrogen graph, if you, I mean, another scenario that we looked at was if we use the same amount of renewables, just as renewables, to replace coal and gas, for example, that would make a much bigger impact. So the opportunity cost is really high here.
Yeah.
But of course, that is we are looking at things from a global perspective. From a national perspective, lots of countries like the UK, where I'm based at the moment, they have plans to reach net zero by 2050, and therefore they would like to use hydrogen to cover that last mile, that last gap, to replace oil
Yeah.
for the aviation industry, for example. So it's there are nuances there. It really
Thank you.
depends which perspective you are taking. We are taking a global perspective,
Yeah.
and yeah.
Thank you. And that it's so key for all of us to consider that, like that last mile idea, and we've often framed it as a hard to abate, like it's going to be appropriate for iron and steel making and these aviation things that where it's going to be very difficult to handle. And people like to use the words addressing hard to abate. The When you take a priorities perspective, however, and you look at a graph like this with the results over this last 20 years, where we've been focusing on competing against coal, oil, and gas, um, the challenge is that we're not addressing the easy to abate. From a priorities perspective, it would lead us back to what shall we be doing that is easy to abate, perhaps, and what should be the priorities. If this could only handle those small sectors, what should we be really focusing on? So I want to get us back there. And so please go to the poll. Please go to the poll. What are the priorities given the rise in coal, oil, and gas and temperature and the urgency? This latest heat wave here in the US and the goals that we have to address this challenge. What are the priorities? If we're going to spend time, investment, and focus to really, and I mean, our mission at Climate Interactive is greenhouse gas emissions falling rapidly with equitable policy. If that's the goal of the world to really meet that goal of staying below 2 degrees, what would we do? 16% set a carbon price, renewable energy, remove subsidies from fossil fuels, reduce methane and other gases, phase out fossil fuels, carbon dioxide removal, discourage wood-based bioenergy. I know Joe is here. You like how I put it that way. Discourage wood-based bioenergy because, of course, it's not carbon neutral. You're burning trees. That hurts the climate in the near term. All right. What else? Carbon price, remove subsidies. All right. Thank you for all your votes. And another note, this is a very rational modeling exercise. This is that short time of vision. What are we doing? We're envisioning the world that we want to see. You're putting your vote towards the policies that you'd really like to see in the world. Okay, please, the next time you encounter En-ROADS, don't do it this quickly. However, what I'm going to do is very swiftly create a future that we really want to see and test those priorities because uh, you can see how much is possible. The Many of you said reducing subsidies. How do you do that in En-ROADS? It shows up as a tax, but halfway here is pretty much removing the increasing subsidies that are around the world. And I'm going to, you saw, I'll do that again. Look in the top left as coal, oil, and gas shrink as we reduce subsidies, 3.1. You talked about carbon pricing, more of this. That still leaves a lot of red, which is oil. You can imagine reducing new oil infrastructure. That's the phasing out idea. Energy efficiency. Look at the way that overall energy use comes down. Now it's already down a lot because energy is more expensive. And in buildings and industry as well. Overall energy use, we're at 2.3. Electrification complements the decarbonization. It would have done more if I had done it earlier. Don't forget the other gases. Methane already shrinks. The blue area of energy production, methane shrinks. Why? Because we just have less gas and coal and oil. But if we're able to cap it and leak it and find the waste, cut the waste, global methane hubs work with satellites and landfills and in wastewater, and then in agricultural emissions. So much can be done there. Look at the yellow area shrink. The yellow area shrink with those agricultural emission actions. When we reduce deforestation, we cut emissions, we boost removals because older trees remove more carbon than younger trees. Watch another drop of zero point 0.1 degree. Perhaps we'll see some carbon removal. Don't count on it. 1.8 degrees. This is renewables in there. And perhaps one thing that makes renewables work better is storage. So you could imagine boosting, look in the top left there, top right, um, storage of renewables, perhaps to handle some of the variability. Overall, this is the kind of combination of actions that could get us to well below 2 degrees. What you see, there's no one big thing. It takes many seeds to plant this garden. It's still possible to bend these curves towards better futures. And the priorities are things that lead us to not burn coal, oil, and gas in the next 10 or 20 years. I'm going to pull up CO2 emissions from fossil fuels. That should be the test of a good policy. What is a good policy? Does it lead us to not burn coal, oil, and gas in the next couple decades? This set of policies brings those CO2 emissions from fossil fuels down rapidly. That's what's needed to meet some of these goals. Now compare CO2 emissions from fossil fuels now from just hydrogen. Was this where we were before? CO2 emissions from fossil fuels. Uh, yes, possibly if we get over all the hurdles in the 2050s, CO2 emissions from fossil fuels slightly lower. This is why we're saying it's not as much of a priority as these other things. Now, many of you say, and a voice in my head says, this isn't possible. This, my friends, is hard. This is the hard work of shifting our policies towards the top priorities that will lead us. And I'm not saying specifically this, any of these prices, but as you know, this is the sort of action that is needed to actually address this climate crisis. Okay, some options for how to learn about this before I go to some more questions. Ava, if you would, please post the invitation to the Mastering En-ROADS course so that you could learn how to engage other people with these ideas in any language, such as if you're going to Belém in the COP, do it in Portuguese, do it in whatever language matters to you. Also, post again, if you would, the explainer, Ava. with the video that teaches you in 7 minutes, not in 50 minutes, how to engage other people. But now I want to look at the Q&A and the chat and to see, and I really try to keep some time here for this, uh, either about the model or I think, Joe Rome, you're here. You're an expert on the actual equipment technology and the policy around it in many ways. But questions about the model or anything. And let's see. Kaveh, is there a question, or Sam, either of you, or Clara, is there a question that you saw or in a chat that you would like to address? What would you like to, is there a question that came up that you would like to address to everybody verbally?
Let's see, there have been quite a few questions, and I've tried to answer them as they come. There was a question about the water vapor, which you covered, the impact of hydrogen leakage on uh, greenhouse gas emission, on the warming effect of other gases, which you covered. There was another question on the use of water resources for hydrogen, which is an important consideration. So making hydrogen based on electrolysis is basically just breaking up the water molecule into hydrogen and oxygen. So it does uh, need quite a bit of water, and that is an important consideration, although we are not explicitly modeling that since our focus is on energy mainly. Uh, then what else? There is a question about the impact being so small because the temperature increase is already baked in by long-lasting GHG accumulations, which is indeed part of the reason, but the main reason that hydrogen is not playing a big role is because it does not help uh, reduce fossil fuel emissions fast enough or steeply enough.
Great. I've
Uh,
seen a question. Joe Rome, by the way, post the book again. How about hydrogen? Joe is texting me about the leakage rate. Um, Joe, actually ask that question, would you? Like, can we, Ava, can you put him on and I want to hear what is your question about leakage? Are you able to like, oh, yeah, there he is. Hey,
Uh,
Joe.
Howdy. Um, uh, what is your baseline leakage rate? I thought I saw when you were manipulating.
Yeah, so I showed very quickly the leakage rates. So here, the rate of leak, yeah, so it indirectly affects radiative forcing, as you know, through affecting the hydrogen cycle. Do you think 2% is reasonable?
No, I think it's low. 2% is probably low for what the natural gas leakage rate is globally. And hydrogen is, vastly, it's the leakiest gas there is because it's
Got
tinier.
it.
It's got a much lower viscosity. It's considerably harder to detect leaks than it is for natural gas. And a lot of people want to use liquefied hydrogen, which is going to boil off. And so, yeah, I think that
Is there a number that you like, or here I am
I
changing
could show you
it?
stuff in the literature. I would say, that it could easily, 5 to 10% would not
Got it.
be.
So
Uh,
just for everybody using this is a moment like when you'll engage other people, you will encounter diversity of opinions about a lot of the parameters. This is a moment when you could say, okay, what is the policy sensitivity? And frankly, if you move this up to 2 or 5, it makes it like, let's see, actually, here we were, temperature is 3.2. If it's 5, or let's push it to 6. Now it's 3.22. So you can see the policy sensitivity to assumptions. In this case, it makes this scenario look even worse. you don't get as much temperature reduction. It's already very little. Thank you, Joe. Are there other questions that have come up in chat? Sam, you see any? Clara, you see any? We are going to stop at the top of the hour and then take any other ones. Uh,
I, Drew, I think Rob asked a question in the Q&A about, we use a lot of carrots, not sticks in the scenario that we created. Maybe you could add in some fuel limits or carbon price on top of the existing subsidies, just to,
Thank you.
yeah.
Thank you. Yeah, here we were. Let's go. So, just for people around the world, the carrot stick analogy. What we did before when we simulated the growth in hydrogen, here we have the production. Here, we took a carrots approach. A carrots approach is incentive. It's the donkey with the carrot hanging in front of them. I want the subsidy that makes them move forward. And so here we have subsidies that would do that. The sticks approach is to say you must have hydrogen, or kind of related is you can't have other stuff. Like, let's stop other ways of meeting this need that will allow for hydrogen to grow. And I think it's one of the places that you could do that is under transportation electrification, where fuel-powered transport sales limit for air and water. This is a what-if experiment. Could you imagine if petroleum gas-based airplanes and ships were discouraged, like in the EU and California, we're saying no internal combustion engines by 2035. There is a precedent for this kind of policy. If you could imagine it for air and water, watch this, I think, yeah. So if you were to say we're going to ban those other sources, fuel powered air and water, not politically accessible at the moment, but this would be more of a sticks approach. We also could put a hydrogen mandate into En-ROADS, but I think the world is so far from that that it just wouldn't be interesting to anybody. Kavi, is there another way to, or Sam, another way to ban the other thing, another sticks approach? Oh yeah, fuel-powered equipment sales limit. Whoa. Uh,
Yeah, Drew, you're not going to be able to get hydrogen in this case
okay.
because we require the infrastructure build out for buildings and
Got it.
industry.
Okay. So, yes, we have mostly looked at carrot approaches, not sticks. Well said. Other questions that have come up?
Oh, Drew, could I make a
Yes.
comment on that?
Yeah.
I think the challenge for the stick approach is that your logical stick approach is going to favor either, as you say, not in combustion, but you could still, that doesn't solve the problem of hydrogen having to compete directly with renewables, right? And if you put a price on carbon, everything is going to drive you to renewables, right? So it's always going to be more efficient to use the renewables directly to replace coal and
Yeah.
gas as power plants, or directly as we're going to electrify transport, ground transport, or heat pumps and replace natural gas and gasoline. So that's going to happen first, right? Unless you put a direct subsidy on hydrogen, right? All you're
Yeah.
going to do is you can drive renewables faster, but remember, the problem for hydrogen is even though you make green hydrogen from renewables, renewables are the direct competitor to green hydrogen.
Great. Thank you. Thank you, Joe. Well said. All right, folks, it is the top of the hour. It is the top of the hour. And so, just to wrap up where we are, top policymakers must get on track with the solutions that are actually going to bend that curve to well below 2 degrees. Right now, the information, the analysis that they get either isn't grounded in the best available science, it's often marketing, it's propaganda, it's lobbying, it's not grounded in understanding of solutions. And the methods that we use to engage people when we think we're changing minds, often we're just throwing information that isn't landing. We need a better way of engaging people on their own terms. The offer we make is this simulator that we hope you, in 21 languages, can bring to others to help them think for themselves, grounded in the best available science. On this topic of En-ROADS, of hydrogen, what we're seeing is that it is not likely to be a priority for addressing climate change because of the reasons you just saw. Even if we got over many of the technological, sociological, political hurdles that there are, it's very inefficient and expensive. It only addresses a small part of a small wedge in overall emissions. And it wouldn't be helping for decades when the priority would be things that lead us to burn less coal, oil, and gas in the next 10, 20 years and reduce methane and the other gases and protect forests. Those are the actions that we need to prioritize. We showed you many of those results. The world can do it to prevent many of the damages of climate change. It's not going to be easy. It's going to be worth it, everybody. Go get them. Bye-bye.